Okay, so we are going to start sort of a new idea in chemistry, and we're going to, well, I guess we did the easy finding the molar mass or molecular weight and percent composition. Now we're going to look at finding the actual amounts of a substance. And so we're going to use a quantity that is called the mole. Um, so this section really lends itself well to learning the topic and then actually practicing the math in the lab. So the last lab we did, observing neutralization reaction, you guys predicted you were going to make NaCl, and then you checked or did a positive test for sodium ions and chloride ions. Now we're going to do something else called percent error, and then eventually we're going to do percent yield. So this afternoon's lab, we're going to do an experiment where you know what you're supposed to get. And again, mathematically, we're going to see what we get, and then you're going to compare it to a known value. And then on Thursday, we're going to look at a way to theoretically or mathematically predict how much product we get. And then you're going to calculate the yield of your reaction. How much did you actually get? So when I was in university, sometimes we would just hand in little vials of our product, and that was it. You got marked on what your yield was, because if you were too far away, like you didn't get as much as you should have, then maybe you had sloppy lab skills and that kind of stuff. So it's just, I would never do that, okay? But it's just a different way of evaluating, you know, different ideas in chemistry. So yes, you can do independent, dependent, controlled experiments like you probably did in grade 9 and 10. You can do positive tests. You can do percent error comparing to a known value, which maybe if you've already taken physics, you would have done that. And you can also look at your yield. How much product did you get versus how much product should you get, okay? We're also going to do filtration in Thursday's experiment, which is a different way of, it's a different lab technique as well. Okay, so sometimes students struggle with, well, what is a mole? How do I see a mole? But kind of the whole point is that you can't see it. So when you have, or you can't see a particle, if you think about, a beaker, a gram amount, whatever, a test tube full of a substance, that is a lot of ions, a lot of atoms, a lot of particles. So we use the mole to count microscopic entities. Okay, so, and the mole is based on Avogadro's number, which is 6.02 times 10 to the power of 23. So this is what it would be, not in scientific notation. So unfortunately, if you hate scientific notation, you kind of have to get over it, because your calculator doesn't, like this, will make it, say error probably. So we're going to have to use scientific notation. So when we do the math, I'll talk about how to use your calculator if you need help. Depending on other courses, if you are a student of Mr. Todd, he usually recommends the Casio FX300ES calculator for reasons like this, because he knows what's coming. Mr. Devine, I know, makes you often put your answers in scientific notation, so maybe you've experienced it in other courses as well. So we are going to use the mole to find the amount of something. So where did they come up with this? We're going to watch a video, a TED Talk. Maybe. Okay, so he, or the person in the video, sort of gave an idea about why the amount of space something takes up is not really useful. What we want to be able to do eventually in chapter 7 is convert between quantities. So if you think about he talked about water, and we'll talk about how he got 18.01, and he showed how much space that would take up. And then when you talk about a gas, and he talked about how a gas particles, they move fast, so they take up more space. So the amount of space something takes up is not a useful quantity to compare. So that's what you guys are used to. What's the measurement of the amount of space something takes up? Mass, right? That's a very common quantity, sometimes converted to volume. So what we need to do, because mass or how much space something takes up is not the same, then it's, that cheesy saying, you can't compare apples to oranges. Well, you can't compare the space something takes up because it's not all going to be the same. So I'll talk more about what these substances are later, but this represents, this black box is 22.4 liters. We'll talk about the amount of gas in volume in the last unit. This represents 1 mole of gas. So if you have 6.02 times 10 to the 23rd particles of gas, this is how much space it would take up. This is a powder. This is 1 mole of a powder. So you can see, very different from the gas. Here, this is 1 mole of a metallic. It is kind of powdery, but a little bit more solid than this. And again, you can see that 1 mole is not the same, okay? So if they're not the same, then that's not useful. What can we do? How can we convert between these values and make them useful? We need to be able to predict how much product is produced. So the way that we do that is the mole. 1 mole of anything, he talked about basketballs, donuts, gas, whatever, is 6.02 times 10 to the power of 23 particles. So this is the symbol for Avogadro's number. If you are a person, if you go home and like Google and say, oh, I just want to watch a video on this topic or whatever, often we will use the word molecules. Your textbook is very specific. So they use the word entity, which basically just means particle. So if you're talking about entity, I don't even think that's spelled right. If you're talking about covalent compounds or molecular, that's molecules. They use the word formula unit for ionic compounds. And you can also switch to the number of ions and atoms as well. So really what we're going to do over the course of this note is change from moles to mass, or mass to moles to entities, whether it's molecules, formula units, whatever, atoms and ions. So the person in the video talked about 1 mole of water being 18.01 grams per mole. That is why the periodic table and the molar mass and molecular weight, that's why I kind of was like, okay, we're going to do this over and over and over again. You guys can watch the video, no big deal, because you need that number to basically do every single calculation you're going to do. So when you have molecular weight, we talked about AMU or U. Now we're going to switch to a more useful unit, again, because eventually we want to convert between substances. So we're going to say that whatever the atomic mass is on the periodic table, then that represents how many grams for 1 mole of a substance. I know this talks about copper sulfate, but he used water in the video. So 2 hydrogens times 1 plus 16, what's that? 18. So that's where he got that 18 grams, because that's the atomic mass on the periodic table. So you can do that for anything diatomic, an element by itself, a compound, pure substance, any of them. So this example is going to review the molecular weight or molar mass, but I also snuck this in there. Now, some of you are asking me about this because it is one of the last questions. We're going to talk about hydrates tomorrow morning as well. So this molecule is a hydrate. So what this means is every single copper sulfate has 5 waters attached to it. So in a really simple way, you can think of it like this. One, two, three, four. Okay? This affects huge. Water is 18. 18 times 5 is a significant mass. It affects the molar mass of the compound. So it makes a big difference when we use copper sulfate in a reaction. So copper sulfate pentahydrate, like this one, is blue. It's obviously much heavier. Anhydrous copper sulfate is like a gross brownish color. So it affects the properties a lot. So this again is bluestone. This is the one that I did that demo for decomposition for. And so if you have algae in your pool, this is algicide. So it's not the same compound when you don't have the waters attached to it. So if you choose to become a scientist or be in a situation where you have to collect your own chemicals, you'll notice that some of the bottles will say anhydrous, like an without water. This is only for ionic compounds. Not every ionic compound will do this. So how do you know? That's why the bottle has to be correctly labeled. Okay? So we have to add these 5 waters in there. So again, maybe if you did a lot of the homework, you're like, okay, I'm really good at this. So if we were going to do something else with this, like mass or moles, which we're going to do in a second, then finding the molar mass, you wouldn't even probably eventually want to even show your work, but here I will, okay? So I'm going to use the symbol MW. If you want, you could do copper sulfate, you could do 5 waters and add them together at the end. You can do it all together. Now, I'm going to write oxy so it doesn't look like 40. Okay, and again, now you have a choice. So water, again, is one of those things that we're going to use so often that perhaps you're going to have the molecular weight of water actually memorized. So then you could do 5 times 15, 5 times 18, but maybe now you don't. So then you would think of this like 10 hydrogens and 5 oxygens. You could do 5 plus 4 is 9. It's all the same. Copper, sulfur, oxygen, hydrogen. When you do the calculations, you don't have to put the units in, but you do have to have it in your answers. So for now, I'm just going to put it in, okay? So you can, again, decide what kind of relationship do you have with your calculator. Because you can do this all as one step. Maybe you want to do this multiplying first and then add it together. It doesn't matter. You should get 249.69. And you have to have units in your answer. So we're basically, for the rest of the quad, we're going to use a calculator virtually every day. So all of the other units are based on quantities. So get a calculator that you like. Don't let anybody else touch it. Sleep with it under your pillow. If somebody comes and says, "Can I borrow your calculator?" you say no. Miss Todd says no. Okay, it's take it out for dinner. Get to know it. And more because too, if you borrow a calculator from me, which is fine, I have some, right? I don't judge. However, you're going to be frustrated. It's frustrating to be on a test or quiz and be like, I don't know how to use this calculator. Then it messes you up, right? You can't focus on the chemistry because you're trying to figure out the calculator. So whatever one you use, just use the same one every time, okay? If you have an iPhone, I know you can turn it sideways and get it to do scientific notation, but again, it's sort of ugly. I don't recommend that. I would call it unfriendly, okay? So, and obviously you can't use your phone on the test or the exam, so there's that too. Okay, good? Okay, so we're gonna watch the beginning of another video where the guy tries to tie the idea of a mole into the periodic table. It's not fancy like the TED Talk one, and we're only going to watch a few minutes of it because then he goes off on his own tangent, but it's not bad. That's enough of that. So that's what we're going to do. What happens if in your lab you don't have 1 mole, you have a different amount of moles, then we can convert between them. They've talked a lot about Avogadro. They've talked about the fact that he died before they could really narrow it down. We're going to talk about Avogadro later on in gases. So his big idea that an equal volume in moles, or equal volume and an equal amount in moles would occupy the same volume. So if you are interested in really the experiments that got to proving and defining what Avogadro's number was, 6.02 times 10 to the 23, then you can check out the article at Scientific American. There were quite a bit of experiments that need to be done, including physics ones like Millikan and his determining the electric charge on an electron. So it wasn't as simple. You obviously can't just count entities, right? So if you're interested in that, I wrote, if you're curious, this is not required reading, but it's there. So, because sometimes students are like, well, what did he do? How did he know? But he really, sort of predicted or hypothesized this idea. And then after he died, then they could prove it, but they still gave him credit. Okay, so how do we find moles? So we are going to use this formula. So if you are a triangle person, you can make it into a triangle. You can also actually do dimensional analysis if you prefer stuff like that. So when we are going to find the moles, so first of all, mole is a weird word, but it also, why didn't they use the symbol M? Well, M is for mass. So isn't that nice? So we're going to we already talked about MW, or molar mass. That's on the periodic table. You never need to memorize that. The unit is grams per mole, or how many grams in 1 mole. N is the number of moles. If chemists, moles is not that long of a word, we use MOL. If you write out moles, that's obviously fine. And then M is the mass. Mass must be in grams, which we abbreviate to G. Has to be grams, not kilograms, not milligrams, must be grams. Again, because we say that the molar mass on the periodic table is how many grams in 1 mole, and you want your units to all be applicable to each other. So when you have the grams, if you divide by the molar mass, if you are a dimensional analysis kind of person, what happens when you divide fractions, you flip and multiply, right? So then the grams cancel out and you're left with moles. So if you like that kind of thing, you can do that. You can also make this a triangle. So multiply down here. This line means divide. Some people say they hate triangles. It really doesn't matter. You can use this formula and plug the values in and then just isolate the unknown appropriately like you would do in math. That's fine too. So at the base of these questions, even though it's like, oh, math, maybe you don't like math, it really is not, we're not going to be transforming sine graphs or anything like that, okay? In grade 12, there are situations where the algebra is a little bit like you have to isolate a variable, get it into standard form, stuff like that. That can be where students make annoying little mistakes, but again, nothing too out there, theory-wise. Okay, so choose your poison. You can do what you like. Just make sure you have the correct unit in your answer. So even if you don't include units to your calculation to keep it simple or whatever, that's fine. Just make sure if you're solving for molecular weight, which you really never do because it's on the periodic table, it would be grams per mole. If you're solving for N, or the number of moles, has to be MOL at least. If you write MOLE, that's fine. MOLES, that's fine. And then M is the mass. So again, you can write the word grams or you can use the symbol G. I don't think there is ever, I don't even think in the homework there's a question where they'll try to trick you and say, what's the mass in kilograms? Like they want you to convert it. They might give it to you in kilograms and you have to change it into grams. Maybe in the solutions unit, we're going to change milliliters to liters. But again, that's it. We're not going to do like nano and pico and stuff like that you might convert in physics. Okay. So we're just going to stick to kilo probably in grams. And when we're doing the test, or exam, I'm not going to use kilograms. I think maybe there's like one question in the homework. Okay, so a sample contains 1.25 moles of nitrogen dioxide. What is the mass of the sample? So when you do these questions, then there is some background information that you need. So for example, if you were given something like this, it doesn't necessarily tell you what nitrogen dioxide is, like the formula. So maybe in your mind, you're like, nitrogen dioxide's NO2 because it says di, which means 2. That's fine. Or if you need to write the formula out, that's fine too. And then so this booklet is chapter 6. And then in the second video, the guy talked about like the coefficients. That's going to be chapter 7 when we look at converting values, which means if you need the coefficients, it has to be balanced. So we do need some topics from the first 2 units in order to do this, okay? So it just kind of depends. It's one of those questions where you look at what you're given and then what you have to find. I know in grade 9, I don't know if you do much math in grade 10, but in grade 9, they're really picky about showing DESCA. We don't really use DESCA here, again, because, you have big grade 11 brains. There's sort of a variety of ways you can solve this problem, but just make sure that you're showing enough work that if you make mistakes, then I can give part marks, okay? And they're not always going to be as simple as this either. So we have MOL, which is moles. So that is the symbol N. And then we need the molecular weight of nitrogen dioxide. So this question would probably be out of 2, maybe out of 3. Can you find the molecular weight of nitrogen dioxide, and then we're going to multiply here, and that's really it, okay? On the test, I usually reserve like units and stuff for the communication section, sort of like in math where it's always at the end. How do your questions look? Can I follow your solution? Do you have correct units? But if you look at the test, it'll tell you what I want, like it'll tell you what the communication should look like or what your solution should look like. So even though I don't require you necessarily to do DESCA, your work has to be neat enough that I can tell what you've done, okay? Your solution can't be wild, right? So I'm going to show my work here. So again, nitrogen on the periodic table is 14. Oxygen is 16. So then, again, decide what you want to do. Do you want to be a triangle person? Do you want to just use the formula and plug in the numbers? Whatever you want. So for this one, because this is the first one we've done, I'll do both. Okay, so on the left side, I'll do the triangle. And then on the right side, I'll just plug it in. So it's up to you if you want to write down both or just one. So here we are asked to find mass. That's what we're looking for. So this is what we're trying to find. That means we're going to multiply what we have. Or if you plug in the numbers here, then your math brain would say, okay, this is dividing. I need to isolate m, so I'm going to do the opposite operation, which is multiplying. So multiply on this side, they cancel, multiply over here. Okay, so pretty simple calculations. You decide what makes more sense to you. Really, you don't even need to write it out like this. Your grade 9 and 10 math teacher probably made you. But in the end, you get the same thing, right? You're multiplying. You could even do dimensional analysis here. So mole in the top and the mole in the bottom, they cancel out. You're left with grams. So these questions in general are the most straightforward, and we are going to do this kind of calculation the most, changing grams into moles and changing moles back into grams. We're going to do that the most often. When we start to apply the mole concept. So even this afternoon, we're going to do empirical and molecular formula. That's applying this. Then we're going to do formula of a hydrate, stoic, limiting reagent. All of that is basically taking the grams, which we can easily measure, converting it into moles so that we can compare substances. Yes? I don't really care, to be honest. Sometimes I write 3. I don't care. You do you. And actually, also, sometimes people get mad at me. They're like, Ms. Todd, your answer doesn't make any sense, because I sometimes will even use my answer button on my calculator. So if you have one of those and you have to do multiple steps, then you actually don't have to clear your calculator out every time. And then your calculator keeps like 7 or 8, which can influence your answer. So let's say you're checking your work, especially with the textbook. If you check your answer in the textbook, they might have it rounded weirdly, like significant digits and stuff. So then your answer just has to be close. So if your answer on the test is close enough, then that's fine. If I'm not sure, I'll check your math and I'll say, oh, I see what they did here. And that's why, too, if you show me lots of work, then it makes it a little bit easier for me to see where you went wrong. And again, you don't need to do both of these. Just pick whichever one you like, okay? Okay, so to find the number of entities, and again, your textbook is very specific, okay? So entities is a general term. So if it's a covalent compound like nonmetals like carbon dioxide, nitrogen dioxide, they're going to say how many molecules. If it's an ionic compound, sodium chloride, that hydrate we just did, they're going to call it formula units, okay? So that is very annoying. And again, if you are the kind of person who likes to Google, like if you Googled calculations with moles, you would find millions of worksheets, millions of videos, whatever you wanted. You might find that people will use molecule sort of for everything. So should they do that? No, but it's one of those things that we just kind of throw that word around. Okay, so again, this one maybe is a little bit trickier, but if you're into dimensional analysis, you can see where the calculation that we're going to do comes from. So Avogadro's number is how many entities per mole in 1 mole of anything. And so if you have the number of moles, if you want to end up with the number of entities, like if you want the moles to cancel out, what math are you going to do? If this is in the bottom, we need to multiply. Okay, because then they would cancel. So again, if you are a dimensional analysis kind of person, then that works here. This will give you how many entities. We can write this as a formula. I'm going to use this symbol, capital NA. It's on the first slide in your note. And then the symbol for moles. You can also write a triangle. Actually, that's not hashtag, that's number. Again, some people, if you choose to look up the videos, they'll call it particles instead of entities. It all means the same thing, okay? When you do these, try not to push out at your brain things you already know. Like, for example, it doesn't matter the order you do the multiplying. Like, if you wrote the moles first and Avogadro's number second, it doesn't matter, right? So don't forget stuff like that. But the big thing here, if you are asked to find the number of entities, molecules, formula units, whatever, you have to have the number of moles. So if you happen to take a look at your periodic table, at the back, now mine's sticks out, yours doesn't. There, you might have seen this flow chart here, okay? So then, depending on what you're given, the question will require more than one step, okay? So if we just did we did moles to mass, but then when you go to entities, you need to make sure you have moles first. So it's kind of like if you start at one end, you could go all the way to the other. You could just do it in the middle. You can't skip steps, okay? Generally speaking, I usually tell students if you forget how to do everything else, if you change grams into moles, you'll at least get part marks, okay? We are never going to compare grams. So as soon as you see grams, change it into moles, and you'll at least get some marks there, okay? Okay, so using the sample from number 1, 1.25 moles of NO2, how many molecules are in the sample? So again, I'm using the word molecule because NO2 is nonmetals covalent. So basically, it's just being more specific about the number of entities. So we already have moles. Now if we're looking for entities, Avogadro's number times the number of moles. You can use the word entity every single time. If you would like to be specific to the type of compound, then use the word molecule. It doesn't really matter. So this is really where you need to either use the scientific notation button that's on your calculator. So sometimes it says, if you have Sharp, it says EXP, or it'll say EE. And hopefully, if you have a calculator that does display, it'll actually do the times 10 for you, and you can see it, okay? Because when some calculators, when you don't use the scientific notation button, what your calculator will do is, depending on how you type it in, they might do 6.02, but then they'll do times 10 to the 23 times 1.5, and it messes up the exponent on the scientific notation, especially when you divide, and you'll get answers like 2.1 times 10 to the power of 47, and you're like, what the heck? Like, that does not make any sense. So you either need to use brackets around the scientific notation number or use the button on your calculator. If your calculator gives an answer like this, okay, it is not writing in the times 10, which is okay. However, you can't write this. This isn't a number, right? So make sure that you're writing in the times 10. So again, really get to know your calculator, use your calculator or the same one every single time so that you're not super frustrated. Okay. So even this one, as long as you remember what Avogadro's number is, this isn't too bad. If you know how to use your calculator, not so bad. The next thing, when you have to change to atoms, if it's molecular, or ions, if it's a formula unit, then that sometimes is the hardest leg of the flow chart. But again, if you think about what you already know and don't push it out of your brain, then all we're doing is applying it to the actual amount of a sample. Okay, so it's not too bad. Okay. So you have already counted the number of atoms. So for example, if we do NO2, then how many nitrogen atoms would you say are in one molecule? How many are in here? N's. One? Yep. How many O's? Oxygens. Yes. Two. Again, if that looks like 20 to you, write oxy. And then we didn't really talk about this before, but you can also do the total, right? There's 1 plus 2, which is 3 total atoms. So this is fine when we were just counting the atoms, and that was it. So this is per one molecule. So if we're continuing with our same example, we don't have one molecule anymore. We have 7.525 times 10 to the power of 23. So then when you're asked for how many atoms, so whether it's nitrogen, oxygen, or total, so read the question carefully, then, because you could do all three here, then you're looking for how many nitrogen atoms per 7.525 times 10 to the power of 23 molecules. So it's like well, there's only one there, so it's the same. But here we have twice the number of atoms, so you multiply by 2. 3 times the number of total atoms, so you just multiply by 3. So the words like per and stuff like that, you've seen those before in math. So again, just try to think of it, even if you say it out loud to yourself, it does really make sense. The annoying part is that they're going to use the word atom for a covalent compound and ion for an ionic compound, which is good. That's right? Covalent compounds don't make ions. However, it just makes it seem more complicated when really you're just doing the same thing every single time. How many atoms or ions are in a molecule, and how many molecules do you have? So then when you look at your flow chart, in order to get to atoms, you have to have entities first, okay? So when you get a question like this, it should say calculate the number of whatever atoms or ions in our sample. So it's not talking about, you shouldn't have numbers like 1, 2, 3 anymore. Now you want to say how many entities do I have, and actually how many atoms or ions do I have, okay? So the number of nitrogen atoms in our sample, yes, there's one nitrogen atom in our molecular entity, but how many molecules do we have? We have this many, okay? This is another calculation that you'll find that you're going to shortcut, and you'll just be like, oh, it's obvious, like I'll multiply by 1, but it's going to be the same. Molecules cancels, you're left with atoms. If you like that kind of dimensional analysis, you can still do it here. Okay. So now we're going to do oxygen atoms. You do the same thing. How many oxygen atoms are there in one molecule? There's 2, but we have 7.525 times 10 to the 23 molecules, so we're going to multiply. How did I write this? So here what happens is you actually get another 0. So you can, if you want, when you do scientific notation, you can kind of ignore this for a second. And if you do 7.5 times 2, like 7 times 7 is 14, right? So then you're looking at 15. So we don't write 15 times 10 to the power of 23. It's like moving it one more spot. So you can kind of check if your answer's right as well. Because you're getting one more 0. Like if you forget this for a second, if you do 7.5, or say you do 7 times 7 is 14, that's another decimal place, which makes it another 0. So this number is actually bigger than 10 to the 23, okay? So yeah, if you haven't used a lot of scientific notation before, these calculations can be definitely annoying, okay? So get to know your calculator. And then I'm going to do this one a little bit differently. Maybe you'd rather think about how many atoms there are in a molecule first and then multiply by the number of molecules. You can totally do that too. So how many total atoms are in our sample or molecule? There's 3. Okay, so the flow chart is on your periodic table. All it says there is it goes through like what steps you have to go through. When we write it on here, I'll try to draw the arrows, but also put the formulas. So then you can use this when you're doing the work. So you kind of have to write small. So if you want to wait until I'm done so you can see, then you can do that. Okay, so if you are given mass, then you'd probably be asked to find moles, I would imagine. And then from moles, you would get entities. I feel like I keep spelling this wrong. There we go. So now this one. This one maybe is one where you would, especially if you're a triangle hater, you would probably not use a triangle, but you can write it in there. And then same with this one. Again, it's the often students are like, I can't do this one. But if you think about it logically, then this one makes a lot of sense. Okay, that's ugly. You know what? I'm going to rewrite this just on the bottom so I can write it bigger. So then when you do these questions, if you're given mass and you're asked for atoms or ions, this question would be worth more marks because you would have to do 1, 2, 3 steps. Okay, you can't skip. Whereas doing even entities to atoms like we would just did is really only worth 1 mark because you just have to do one calculation. Okay. So the examples we're going to do next, well, the first one is dividing with scientific notation. So again, this is where sometimes people will, their calculator is weird and it will give them like times 10 to the negative 47 and stuff. And hopefully that's your clue. That does not make any sense for what we've done. You'll notice that a lot of the questions, the answers are very similar. The number of moles is often less than 1. The number of grams is usually greater than 1. The entities and stuff is usually like 23, power of 25, power of 24, right? It's not outrageous numbers like to the power of 47. So hopefully if you do enough of the practice, then you'll be like, okay, my answer sort of makes sense, or no, it doesn't. Okay, so this one, we are given the formula units, which again, your textbook just specifically uses for entities. Because sodium chloride is an ionic compound. How many moles does the sample contain? So in all these questions, it almost looks like you're not given enough information. So you need to remember, oh yeah, molecular weight I can find with the periodic table, and Avogadro's number is always 6.02 times 10 to the power of 23. So even if you forget who Avogadro is, what the name of the number is, as long as you remember that it's 6.02 times 10 to the 23 particles, entities, formula units, whatever, in 1 mole of something, and how to use it, that's good enough, okay? Actually, I can even short form it. You can even have fun with yourself. The short form for formula units, FU, haha. Okay, so chemists are lazy, we love short forms, but in this case, maybe dimensional analysis isn't going to help you. But you can think of this like everybody in grade 9 math has to learn this. So maybe you even learned it in elementary school. We're trying to isolate n. Here, this is multiplying, which means we have to divide, okay? So again, if you struggle with this kind of stuff, then show as much work as you possibly can. This is multiplying. I need to isolate n. I'm going to divide. What you do to one side, you have to do to the other. Okay? This is the same, cancels out. And then this is really, again, where you separate the men from the boys in terms of calculators, okay? So if you don't know how to do scientific notation, EXP or whatever, then you must put these numbers in brackets. If you do 4.59 times 10 to the power of 19, then put that in brackets and then divide by 6.02 times 10 to the power of 23. If your calculator, if you use the EXP or whatever, your calculator will know that that means that that's a number and you don't have to use brackets. So it's really up to you. You should get or if your calculator uses scientific notation, that's totally fine too. I don't care. Okay? If you need help, let me know. And again, students just get frustrated. I hate my calculator. How do I make this work? Yeah, so that's just times 10 to negative 5. So you can write 0.5 if you want, or just 5. You okay? Okay. Now, this example, I wrote less easy because we're going to have to do more than one step, okay? So it says how many hydroxide ions. So that is the last part of the flow chart, right? And what are we given? We're given moles. So we have moles, but in order to get to ions, you have to do entities first. Or in this case, it's ionic compound. If you'd rather write FU or formula units, that's fine, okay? It all means the same thing. I'm going to write out what I'm doing. When you do the homework, you don't need to calculate entities first, but just so that when you go back and look at this, you know what I've done, okay? Calculate. So even though this question has more than one step, we're doing, again, here we go. We got to find the number of entities. There's 6.02 times 10 to the power of 23 entities in 1 mole. Do we have 1 mole? No, we have less than 1. That means that we should get a number that's less than 6.02 times 10 to the 23. I got, is my number less? Yes. You could even go further. This is even less than half. So this should be, my answer should be less than half of this. So 6 divided by 2 is 3. It's less than half. So there's lots of ways you can kind of logically check your answer. So even though today's annoying and maybe you're like, oh, all these numbers, what's a mole, whatever, eventually we're going to do this over and over again. And it'll be like, oh, it's kind of nice to be able to, quantify. Like yesterday, Miss Coolin's grade 9 class did the flame test where you put the loops, and they were like, is this orange? Is this yellow? Is this pink? Is this purple? Qualitative analysis isn't always exact, right? So moving towards quantitative is a little bit better and a little bit more logical, and who doesn't like that, right? Okay, so now now we have entities, so now we can calculate the number of ions in our sample. So again, if you're like, I forget what hydroxide is, you're always going to get the same periodic table. Go look it up, just even as a security blanket for yourself, okay? Let's say you don't remember how to do this, but you know how to find the number of entities. Don't leave the whole question blank. If you know that's what you've got to do, then do it. Let's say you're like, okay, I know this is moles. I'm going to find the number of entities. I'm going to find the mass. Even if you do work that you don't have to do, I would never mark that wrong, but maybe in there you'll get some part marks, okay? So we want the number of hydroxide ions in the sample. So go start from what you already know, okay? So what do I know? How many hydroxide ions are in iron 3 hydroxide? How many? If I asked you to balance this, you would count 3, right? Okay, so you know that. So start with what you know. So whether you write entity, whether you write formula unit, even to be honest, if you wrote molecule, I would not mark it wrong, okay? Like I said, there are plenty of people out there who just shove them all in the same category. So 3 hydroxide ions per formula unit. How many formula units do we have? Oh, we have 2.107 times 10 to the power of 23. Again, you can cross them out if you're into that. You may notice the more practice you do, for example, here, if you have more than one step, I wouldn't clear your calculator. Just leave it in there, and then all you're doing is multiplying by 3, okay? And then you don't have to retype this in every time, and it can kind of streamline your work. So the homework I've listed there is also on D2L. So all of the solutions are on D2L. They're also beside Danica, but, kind of stay away from her. The cases are rising. We don't really know what's happening, so try to stay away from people. And but they're all on D2L, okay? The questions are not all the same. So what I did was I divided them. This question has to do with like the theory behind the moles. Then if you just want to practice mole and mass, that's these ones. If you want to do entities, that's these ones. And then going all the way to atoms and ions, specifically are these ones. All mixed together is the section ones at the end, okay? So you decide what you want to do. To be honest, I forget in the back of the book if they just have the answer, or in the practice ones, it might even actually be in the question. But then again, I've got full solutions for everything, okay? So when you go to D2L, I can't remember what last unit was like, but this one, It's got a list of the homework, and then the solutions are the next file. Okay. Now, if you click on the solutions, it has it usually at the top as well what the questions are. So there's more than one way to find it. Okay. So we do have some friends missing. There will also be the video will go with each of the lessons as well. Okay. So